Lesson 15.3, Task 4. All right, special products of binomials. Find the square of a sum. All right, square of a sum pattern. So we already looked at this in Task 2. A plus B quantity squared equals A squared plus 2AB plus B squared. All right, so a perfect square trinomial is a trinomial that is the result of squaring a binomial. The trinomial a squared plus 2ab plus b squared is one form of a perfect square trinomial. All right, so multiply x plus 2 squared. All right, so I want to look at this closely because a lot of kids forget the middle term. And if you forget the middle term, you're going to get it wrong. So it's very important to make sure that you get that 2ab in the middle. So understanding what that is very important. So if you've got x plus 6 squared, if you do x squared plus 36, that is wrong. Okay, so a binomial squared is x plus 6 times x plus 6. Anything squared is something times itself. So you're going to have x times x plus 6, and then plus 6 times x plus 6. We're using distributive property like we've learned in the previous unit, or previous lesson. So we've got x squared plus 6x plus 6x plus 36. And you can see in the previous one, the middle terms cancel. This doesn't cancel. It becomes double. So it's going to be x squared. 6 plus 6 is 12x plus 36. So when it talks about this being twice AB, whatever AB are, this is considered A plus B quantity squared. AB is 6x. You're going to double that to get 12x, okay, because it's squared. So the result of x plus 6 squared is x squared plus 12x plus 36. All right, explain how you can check the answer. All right, so you can use the table, you can use distributive property, or you can factor this back out if you want to and see if you get what you started with. All right, let's do another one. Multiply 2x plus 2y quantity squared. Again, you're going to do the same thing because it's a binomial squared. So we've got a plus b squared. In this case, 2x is a and 2y is b. So you're going to square 2x and make sure you square both the number and the variable. So you're going to get 4x squared. And then you're going to get twice a times b. A is 2x, b is 2y, and you're going to double that. So if I have 4xy, in the middle, I'm going to have 8xy because I have to double 4. All right, at the end, I've got 2y squared. Again, you square both the number and the variable for 4y squared. All right, which of the following calculations show how to do 2y squared? So you square the 2 and you square the y. All right, that's all for this example. And again, this is called a perfect square trinomial. Again, one of those important concepts that you will see even later on the ACT. All right, that's all for task 4. If you have any questions, let me know. Lesson 15.3, task 5. All right, so we're still talking about special products of binomials. So this time we're going to find the square of a difference. Okay, difference means subtraction, so it works very much like the sum of addition. Okay, so the square of a difference pattern. So we've got a binomial squared, so it's going to equal a squared minus 2ab plus b squared. So remember in the last one this was plus and this was plus, and that's the only difference. So when we have a difference pattern, it just means that the minus goes in the middle. Remember, anything squared is positive, anything squared is positive, so the only difference is the sign in the middle. That's the only change. All right, so a trinomial, a squared minus 2ab plus b squared, is the other form of a perfect square trinomial. All right, so we have a perfect square trinomial, means 3 terms. Okay, so when we square a binomial, we get a perfect square trinomial. All right, and the reason is we've got x minus 8 squared, which again is the same as x minus 8 times x minus 8. And you can see that they've plugged it into the formula here. And they've done the first term squared. In this case, the first term is x, and we're going to square x. And then you're going to have minus 2 times the middle term, or 2 times AB. So 2 times whatever this is, so that's going to be 8x times 2, and then of course the negative goes along with it. We always have the negative in the middle when it's a difference here. So we're going to have negative twice times AB, and then plus b squared. B is always the second part of your binomial in this term. So you've got x minus 8, x is your A, 8 is your B. All right, so when you simplify the middle, negative 2x times 8 is negative 16x. Again, that's just twice AB. So x squared minus 16x plus 64 would be the perfect square trinomial when you multiply this by itself, or x minus 8 quantity squared. All right, so choose the correct words to complete the statements. The product is the square of a binomial, because we're taking a binomial and we're squaring it. So its result is a perfect square trinomial. It has 3 terms. That makes it a trinomial, which has 3 terms. So remember, a binomial has 2 terms. When we square a binomial, then we're going to get a trinomial. All right, so multiply 4 minus x squared squared. So this is a binomial squared. So we're going to take the same formula, even though before we've had our variable in the beginning. It doesn't really matter which one comes first. So this time our a is 4 and our b is x squared. We're still going to do the same thing. We're going to square a, so 4 squared. We're going to do minus 2 times ab. A is 4, b is x squared in this case. And then we're going to square our b term, which is x squared. So x squared squared is x to the 4th. So 4 squared is 16 minus 2 times 4x squared is minus 8x squared, and then plus x to the 4th power. All right, so choose the correct expression to complete this statement. The expression 4 replaces a, and the expression x squared replaces b in the general rule. All right, if you wanted to write this in standard form, it would be x to the 4th minus 8x squared plus 16, and the degree would be 4 because that's the exponent, and the leading coefficient is a 1. All right, so that's just review from the previous unit, but we don't want to forget that either. All right, so that's all for task 5. If you have any questions, let me know. Lesson 15.3, task 6, apply special products. In a center pivot irrigation system, the irrigation system is stationary at one end, where the water source is located, and the rest of the system rotates around the fixed end to cover a circular region. The radius of the circular region is equal to the length of the irrigation system. All right, so you can see in the picture, you've got X, 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 X. So there's 4 sections that are X length, feet long, and then one that is an additional 8 feet. So it says a farmer will have a center pivot irrigation system installed in a crop field. The length of each section, X feet in the photo, varies depending on the model, but the 8-foot extension on the far end remains constant. The farmer plans to have 4 sections of length X feet installed as shown. Write the area of a circular region covered by the irrigation system as a polynomial in standard form. All right, so the first thing you need to know is what is the formula for a circle. All right, so it says write an expression for the radius of a circular region. So the area of a circle is area equals pi r squared. So we have to find the area, so we have to find the length of the radius, which is our r in the formula. So the length of the 4 sections is x feet, so there's 4x feet. and there's an 8-foot extension. So we can label this as 4x plus 8, and that would represent our radius. All right, so to determine the area, we're going to use the formula for a circle, which is A equals pi r squared. Since the radius of the circular region is 4x plus 8 feet, the area of the circular region is area equals pi r squared. 4x plus 8 squared is our radius squared. And that's going to be feet squared because we're talking about area, which is squared. All right, so we're going to have to take 4x plus 8 and square it. So we're just going to leave pi, bring it along for the ride, and then we're going to square the first term like we've done. 4x squared is 16x squared. And then we're going to have twice AB, so 2 times 4x plus 8. And then we're going to square our last term, which is 8 squared. All right, so when you simplify that, 4x squared, remember you square both the 4 and the x, you get 16x squared. And then the middle, 2 times 4 is 8. 8 times 8 is 64x. All right, and then 8 squared is 64. All right, so then now distribute the pi. Since pi is outside the parentheses, that means you multiply it by each term. So your final area is 16 pi x squared plus 64 pi x plus 64 pi. Yes, pi is an irrational number, and you could actually take that number and multiply it by each number here. Sometimes they do that, and sometimes they just leave it in terms of pi, since pi is irrational. All right, so it says what rule is used to multiply this? So this was a square of a sum, which we've been looking at in this lesson. What is another way you could obtain the product? You could also use distributive property, which we have done. And it says the area of a circular region is 16 pi x squared plus 64 pi x plus 64 pi squared feet, where x is the length of each section of the irrigation system. All right, so in this polynomial, the term 16 pi x squared represents the area watered by, and that would be the x terms, this 8 foot, or the 4 sections that are length x. And the rest of the term is represented by the 8-foot section. 8 squared is 64. Remember, that's just an easy way to check it, but that's how you would find the area of a circle. All right, that is all for task 6. If you have any questions, let me know.